Okay, students. Today this is the last operation in single linked list, that is deletion. After completing the deletion, we will go to the doubly linked list. In the previous video, we have created the code for insertion, and before that, in the first tutorial, we have only created a simple program that you can see. In this program, we have just created create function and the display function. We have just discussed how we can create a linked list and how we can traverse the linked list. Then in second tutorial, we have discussed the code of insertion, and today we will discuss delete. And deletion also can be done by three ways: from the beginning, from the end, or from a specified position. So in overall structure, you can see this is overall program. You will be surprised how this overall program is looking very small. This is the feature of code block. That's why I was saying you should prepare your programs in code block. Why? These are the blocks of your code. You can see this is the block of main. This is my main block, so I can easily see what I have done in the last video. We have called insert operation, which we have created, and called it this function into the main, then display, then again we ask the request to the user whether he want to continue or not. So now the same procedure as we have discussed in insertion, similarly we are taking this while loop that is totally same. There is nothing different, but the difference is of this function. In the previous we were calling insert. Here we have to create a new function, that is delete node, and similarly we will call the delete node function into this block. Clear? So do you want to delete? We have to change the printf function also. In this function we have given this do you want to insert, and here we are saying do you want to delete a node from the linked list, nothing else. Rest of the things are totally same, so I am not wasting my time. So now come to this block. This is deletion, no, delete node, sorry. So now I'm opening. I have already typed to save the time and to make this video very small and very, so you can see I have already typed all the text which we have already discussed in the previous videos, so there is no need to go into the detail. These are the normal variables, character variable and integer variable, and similarly these type of variables we have taken in insertion. Why we are taking node number 1? Because we have to count the nodes, so we are starting from 1. Delete node, which delete you want to delete, so we have to give the choice, so this is another variable. And node is equal to start dot next, means we are giving control to the first node. We are calling first node as a node and start as a previous. So these all things are already discussed. These are the printing functions in which we are saying to user whether you want to delete from the beginning or from the end or from the specified location, and this choice is coming in the get chr function. So it is very easy. I'm not discussing again and again. Now come to the deletion. Deletion, the first choice. Suppose a user want to delete from the beginning, then my responsibility is first I have to check whether the linked list is empty or not. If node is null, it means the first node is not there, the linked list is empty, so we have to print the underflow condition. Else we have to say previous arrow next, means start arrow next should be node arrow next. What does it mean? Because we want to remove the first node, so we have to free before doing do the free of that node. First we have to allocate the address of second node to the start arrow next. Then now previous, or you can say start, is holding the address of second node, so now you can just free the node. Then this is the deletion from the beginning. Only this small code will delete the node from the beginning. In the second choice, suppose you want to delete the node from the end. Now there is a slight difference. Again we have to check whether the linked list is empty or not. If it is empty, then you have to print this is the underflow condition. Otherwise you should reach to the last node. I have already discussed traverse code in the display function. You can go into the detail. If you have not done, then see the previous videos, and that is discussed in detail. Node arrow next is not equal to null. While node arrow next not equal to null, node is equal to node next, previous is equal to previous next, node number that was starting in starting, that is 1. So we have to move from 1 to the last node and count how many nodes are there. So this is the last. Suppose the linked list is having 4 nodes, then we have to move from first to the fourth node, then we can only delete. So this, what does it mean? If we are calling it while node, that is okay, that is another type of traversal code. But in this we are saying node arrow next not equal to null. While node arrow next, suppose I am on the last node and last node next is null. Okay, so it will move to the directly null, and previous code will reach to the end node. So now we can say we are standing on the last node and the null. Now before deleting the node number, I'm printing the node number. What is the node number and what is the value of that node which we are going to delete? So this is only a display to make the user friendly program. Now previous next is equal to node arrow next. Node arrow next is what? Node arrow next. Node is the actually last node which we want to free, and this is the previous one. So we have to allocate the node arrow next. Node arrow next means this is the node is the last node, and no last node is having the address of nothing, that is null. So we have to assign null to the previous node. Okay, so now free the last node, and second last node, which is represented by previous arrow next, will be allocated by null in the place of next, which is holding the address of next node. Now suppose user want to delete from the specified position, input node number you want to delete, and then give the node number. Suppose I want to delete the second node or the third node which you want to delete. Suppose I want to give the third node I want to delete. So my while node, that is a simple calling of traversal. This loop will be executed when the node is there. If node number is equal to delete node, the delete node is 3 and node number initially was 1. So now previous arrow next is equal to node arrow next. When we will call it? When these two things are equal. In my starting, previously my node number is 1 and delete node number which is given by user, that is 3, which is not equal, so I will go to the else part. This is also discussed in insertion. So similarly we are doing this, most of things are same. Else node is equal to node next, previous equal to previous next, and node number plus plus. So now node number is 2. Now again node number 2 is not equal to node which is given by the user. So now go to the else part. Node is equal to node next and previous is equal to previous next, node number plus plus. Now node number is 3. Now go to again check the condition, if condition. Now my node number is 3 and number given by user, node number given by user is also 3. Now it is equal. Now the condition is true. Now previous arrow next, what does it mean? We are on which node? Node is on node number 3 and previous is on node number 2. So now node number 3 next is having the fourth node address, or suppose third node is end, then it is having the null. So we have to just assign the value of that to the previous one. So means suppose third node is having the address of fourth node, then fourth node address will be assigned to the second node and node number 3 will be deleted, or you can say we will free the third node. So this is the overall program. So now I'm going to compile this program. It is very user friendly. If there is no error, then you can see it. No errors, 0 errors and 0 warnings. So now run this program by Control F10. So enter the value to the node. Suppose my first node value is 12 and input choice is n. So I'm not doing or not creating second node or third node. I have just created a linked list with the single node which is having the value 12, and next part is having the null. Now my second function was the insert, which I already discussed in previous one, but now I am going to insert again. Suppose I want to insert a node in beginning. I'm giving the choice beginning, and my first value is 1000. Now I want to insert, yes, and now I want to insert my node in end, and that is suppose 3000. Now you can see an end in the previous, or you can say in beginning, is beginning, and the end we have inserted. Now uh, third choice is at the specified position. Yes, I want to insert at a specified position, suppose that is second. Okay, this is not a choice. I have to give it here. I have to give the I first. Do you want to insert into the linked list? Yes. Specified position is, I have to press I. Now node number is second. There were mistake. So now node number second value I want to insert 2000, because I'm taking just different values, so we can easily see it in the output. So now at second position 2000 is inserted. In the beginning 1000 is there, in end 3000 is there, and previously I generated this linked list with the only single value, that was 12. So now I'm not interested in the insertion. Now come to the second part, which we have just created, this deletion part. Again it is having three choices: beginning, and specified position. So I'm giving choice B in the starting. So it will remove 1000. Check it whether it is removing or not. Yes, 1000 is removed, and now the output is the second node comes in place of first node, and rest of linked list is same. Now do you want to delete again? Yes. Now I want to delete from the end, so I'm pressing E. Now what was in the end? That was 3000. So now 3000 is removed. Now my choice is, I want to delete. Yes, suppose I want to delete from a specified position. Now I have no more choice. I can delete only from the node number 1 or node number 2. So 1 maybe apply by the beginning, so I'm just giving remove or delete the node number 2. Clear? So node number 2, that was 12, that was deleted. So here we can just enjoy the singly linked list with these operations. Run these programs again and again, and enjoy the linked list. Now in coming video lectures you will see, because in W linked list, in circular W linked list, or uh, singly circular linked list, and some other operations like stack and queue, implementation of stack and queue using linked list, these all topics are totally based on singly linked list. So I request all the students, please go into the detail and do the practice of singly linked list as you can do. Repeat it, at least you have to repeat it at least 4 or 5, or you can, if you can repeat it 10 times, then this is not a very big number. So it is very easy. Do the practice again and again. Enjoy the linked list. Best of luck. Thank you so much.